Welcome one and all. In the previous video we have discussed about how to identify or how to convert a non-exact differential equation as an exact differential equation with one type of integrating factor 1 by mx plus ny whenever the given dE is a homogeneous dE. Now we will see another model in this case, how to convert a non-exact differential equation into exact differential equation by taking the integrating factor of the form 1 by mx minus ny. So now first of all, how to identify such type of differential equations and then how to solve that. So one by one we will see. Let us suppose that the differential equation is of the form as usually in the standard form m dx plus n dy is equal to 0. Suppose that this differential equation is non-exact. It is a non-exact dE, but if this differential equation is of the form some y into f of xy dx plus x into some g of xy dy is equal to 0, then we can say that the integrating factor is of the form 1 by mx minus ny. So of course, provided mx minus ny is not equal to 0. Okay, so the differential equation is of the form as usually m dx plus n dy is equal to 0. So therefore we have tried for by using dou m by dou y, dou n by dou x, but we got it as not exact. And if the dE actually is of the form something like this, means here we should have the product terms, some y into f of xy and x into g of xy dy is equal to 0. In the sense, after taking y as common from m, still we have product terms in m. After taking x as common in n, still we have the product terms in n. Then we can say that 1 by mx minus ny is an integrating factor. Okay, so if we can identify a non-exact dE is something like this, some y into f of xy dx plus x into g of xy dy, then we can say that the integrating factor is of the form 1 by mx minus ny. We will discuss this with the help of one example, one problem we will discuss this. Now suppose we have an equation something like this. So y into x square y square plus 2 into dx plus x into 2 minus 2x square y square dy is equal to 0. So first of all, as usually it is of the form m dx plus n dy is equal to 0. So we will check it whether it is exact or not. First of all, step by step one now we will see. Step by step procedure now we will follow. So first of all, to verify the exactness of equation 1. So equation 1 is of the form so what is that? I am writing here m dx plus n dy is equal to 0. Okay, where so if you identify here where m is equal to, what is m here? So y into x square y square plus 2 means now you multiply this, then what we get? X square y square into y means x square y cube plus 2 into y means 2y. Okay, and n is equal to so if you observe here, now you multiply with x, then we will get 2 into x, 2x minus 2 into x square into x means x cube into y square. So that is m and n what we have. Now you calculate the partial derivatives. Now dou m by dou y is equal to, so here x square is a constant, derivative of y cube is 3y square. So therefore we will get x square into, because x square is constant and y derivative of y cube is 3y square. So x square into 3y square plus 2 into 2 is a constant and derivative of y is 1. So therefore we will get it as 3x square y square plus 2. So this is what dou m by dou y. Similarly we will calculate dou n by dou x. So means the partial derivative of n with respect to x we will try to find out. So dou n by dou x. So means here y is treated as constant because we are partially differentiating with respect to x. So 2 into derivative of x is 1 minus 2 into derivative of x cube is 3x square and y square is a constant, leave that. So means here we get 2 minus 2 3s are 6, okay, 6x square y square. So if you observe both are not same, so you take it as equation A and this one as B, then so therefore we can conclude that, therefore from A and B what we can conclude, dou m by dou y is not equal to dou n by dou x. So therefore equation 1 is not exact, or equation 1 is not an exact differential equation, like that also we can write. So once as we identify the given dE is of the form sum m dx plus n dy is equal to 0, so our primary motto is to check whether it is exact or not. So that's why we did. So we have calculated dou m by dou y and dou n by dou x, both we did and found that both are not same, means the equation is not exact. Now but if you observe, this equation is in the form of some y into f of xy, because there is a product term here. So here we have a product term and here also we have a product term. So means, now you write actually, so equation 1 is of the form, so if you observe that some y into f of xy dx, sorry, one second, y into f of xy dx plus x into g of xy dy is equal to 0. Okay, so after taking y as common, here we have a product term, and after taking x as common here also we have the product term x square y square. So therefore just by comparing the given equation with the standard form, we got it, it is in the standard form. So therefore now we can say that the integrating factor, therefore the integrating factor of equation 1 is of the form 1 by mx minus ny. Of course mx minus ny is not equal to 0. Now we will check the value of mx minus ny. Now we calculate that one. Now you consider mx minus ny, so which is equal to, so here we have m, so m is equal to x square y cube plus 2y here we have. Now you multiply this one with, here what we does that x, so x into x square y cube means we get x cube y cube plus 2y into x means 2xy minus n into y. Ny we have, so here we have n is 2x minus 2x cube y square. You multiply this one with y. So 2x into y means 2xy minus, so here we have negative sign, but here we have one more negative, so you will get plus, so 2x cube y square into x means we get 2x power 4 into y square. So here plus 2xy minus 2xy both will cancels out. Sorry, here not it is with y we are multiplying with 2x cube only, here we will get x cube, 2x cube y cube here we will get. So here we will get 2x cube y cube, sorry for this, okay, because we are multiplying with y means we will get 2xy minus plus 2x cube into y square into y means y cube we will get. So here we have x cube y cube plus 2x cube y cube means here we will get 3x cube y cube we get, so which is not equal to 0. So therefore the integrating factor, is equal to 1 by mx minus ny is equal to 1 by 3x cube y cube. So now the integrating factor is nothing but 1 by 3x cube y cube. Now we will multiply the given differential equation 1 with this integrating factor, and then automatically that equation reduces or transforms to an exact differential equation. Okay, that we will see. So here what is integrating factor? 1 by 3x cube y cube. Now we multiply the given dE with 1 by 3x cube y cube on both sides, then we will solve that one. Now we will see in the new page. So 1 by 3x cube y cube, this is the integrating factor, into the differential equation, we will write it. So here we have m, we will take x square y cube plus 2y x square y cube plus 2y into dx. Next we will see the next term. So here what is n? 2x minus 2x cube y square, 2x minus 2x cube y square, 2x minus 2x cube y square into dy is equal to 0. Now you simplify this. This implies what we get. So x square by x cube, y cube and y cube cancels out, and we will get 1 by 3x plus here 2 by, so 3x cube, y cancels out in y cube means we will get 3x cube y square whole into dx plus, similarly here also, so 2x by 3x cube y cube, so 2 by 3 x cancels out in x cube, then we will get 2 by 3 x square y cube minus 2 by 3 x cube and x cube cancel out, and y square by y cube means we will get 3y only, whole into dy is equal to 0. So take this one as some equation 2. So if you observe, equation 2 is of the form some m1 dx plus n1 dy is equal to 0. So if we want, we can check whether equation 2 is exact or not. So if you want, you can verify. Actually not necessary, but we will try to verify the exactness of equation 2. Okay, so here we have what is m1 and what is n1 directly. Now I am calculating the partial derivatives. Now dou m1 by dou m1 by dou y is equal to, so here with respects to y means x is a constant, means the derivative of 1 by 3x is 0, and derivative of 2 by 3x cube is also a constant, so means here 0, plus here 2 by 3x cube is also a constant, 2 by 3x cube is also a constant, and then we have 1 by y square. What is the derivative of 1 by y square? 1 by y square means y power minus 2, and derivative of y power minus 2 means minus 2 into y power minus 2 minus 1, in the sense minus 2 by y cube. So therefore here we can write minus 2 by y cube, we can write it. So that is the derivative of 1 by y square. So means here we will get minus 4 by 3 x cube y cube. That's what dou m1 by dou y. So if you want, you can take it as some equation C. Okay, so similarly now we will calculate the partial derivative of n1 with respect to x, means dou n1 by dou x. Now we will calculate. So dou n1 by dou x means here we have to take y as a constant. So here 2 by 3 y cube is constant, and derivative of 1 by x square. So derivative of 1 by x square, just like that we did for 1 by y square, minus 2 by x cube we will get. So what are the constants here? 2 by 3 y cube is constant, and derivative of 1 by x square is minus 2 by x cube. Okay, now coming to the second term, minus 2 by 3 y we have, but we are partially differentiating with respect to x, means the derivative of minus 2 by 3 y is 0, means minus 0 here we will get. So which is equal to what we get finally, minus 2 into 2 minus 4, minus 4 by 3 x cube y cube we will get it. So you take this one as D. So if you observe the equations C and D, both are nothing but same, minus 4 by 3x cube y cube, just the same you can conclude. Therefore from C and D, or otherwise therefore from the equations C and D, so we can conclude that dou m1 by dou m1 by dou y is equal to dou n1 by dou x. So means therefore equation 2 is exact. So this is how, just by multiplying the given dE with the integrating factor 1 by mx minus ny, we can convert that one into an exact differential equation. And later on we know, once if you know or identify an equation as exact, how to find its general solution. So therefore the general solution of equation 2 is given by, so what is the formula? We know that, you know the formula as integral of treating y as a constant m1 dx plus integral, so we have to write the terms in n1 which are free from x whole into dy is equal to c, where c is nothing but an arbitrary constant. So this implies, now we have to take the terms in m1. So what is m1 here? So m1 here is nothing but, here we have 1 by 3x plus 2 by So here what we have, 3x cube y square, we have 3x cube y square whole into dx, plus in the second integral we have to take the terms in n1 which are free from x. Now here you check it, this is totally n1. In this one, in the first term we have the term x, but in the second term we don't have x, so that's why we can take minus 2 by 3y. So minus 2 by 3y whole into dy is equal to c. Okay, now we will go for the integration. So integral of 1 by x is nothing but log x, and here y is a constant, means 2 by 3y square is constant, means you can write plus 2 by 3y square into what we have, 1 by x cube we have. So what is the integral of 1 by x cube? 1 by x cube means x power minus 3. So what is its integration? X power minus 3 plus 1 divided by minus 3 plus 1, in the sense x power minus 2 by minus 2. So means integral of 1 by x cube, now we can write it as minus 1 by 2x square. So here already we have minus 2 by 3 is a constant in the second integral, minus 2 by 3 into integral of 1 by y. Integral of 1 by y is nothing but log y. Log y is equal to c. Okay, now if you want we can simplify that more, because some of the logarithmic functions and all differently we have. So then now we can calculate it, just we can simplify this. You just multiply on both sides with 3, then we can write it as log x. So negative sign here we have minus 1 by 3 x square y square minus log of y square. This is 2 log y can be written as log y square. So if you multiply with 3 means totally here 3 cancels out, here 3 cancels out, here also 3 cancels out, and here also 3 cancels out, but right side we will get 3c. Okay, so means now we can write it as by using the logarithmic formula. So log x minus log y square can be written as log of x by y square is equal to 3c, plus this term we can write it as on the right side 3c plus 1 by x square y square. Now totally we can write this one as, by using the logarithmic formula, x by y square is equal to e power 3c plus 1 by x square y square. Now we can take this 3c as some c, e power 3c as some c1, then we can write x by y square is equal to some c1 into e power 1 by x square y square, where c1 is nothing but e power 3c. Okay, or otherwise if you want to write it in one line, then we can write it as x is equal to some y square into what we have, c1 y square into, we can write it. So x is equal to c1 y square. So x is equal to c1 y square into e power of 1 by x square y square, and of course what is c1, we have e power 3c, and finally, so that is the general solution of the given differential equation. If you want, you can conclude like this. So which is the general solution of the given differential equation 1. So this is nothing but the formula we have taken here for the general solution of equation 2, because 2 is exact, but finally whatever we will get this is nothing but the general solution of equation 1. So this is how, if the given DE is identified as non-exact DE, but it is in the standard form of sum x into f of x into y into f of xy dx plus x into g of xy dy is equal to 0, then we can take the integrating factor as 1 by mx minus ny, and by multiplying the dE with 1 by mx minus ny, we can convert into some m1 dx plus n1 dy is equal to 0. If we want, we can check it whether the given dE is reduced to an exact dE or not, and we can find out its general solution like this. Okay, thank you very much. Thank you one and all.